now we're going to take a look at composition of functions. And what composition of functions is, it has this goofy little 0. Okay? Now, I don't know, I said it, I didn't really specify, but when we're reading these, this is supposed to say f of x. There's like an imaginary of word in here. Okay? So when this is over here, we have g, and there's like an imaginary little of x. So it's g of x is 4 divided by x minus 1. When we have these functions down here like this really says f of, it's like an imaginary of, g of 2. So it's composition. And so you've got to do multiple function work on these problems. Now what I always do is I have my students circle the number and the closest letter that it's next to. And that's where you're supposed to start with these composition of functions. So what I do is I take the 2 and I'm supposed to plug it into the g function first, whatever it's next to. Okay? So I take the 2 and plug it over here. Now that means I'm supposed to put a 2 wherever there's an x. So really that means 4 over 2 minus 1. And if I work that out, I'm going to get 4 over 1, which is just 4. Okay? So what that means is that g of 2 is 4. Okay? And so now I take this g of 2 part and I can cross it out and replace it with a 4. Now I want f of 4. So this hard-looking problem just turned into really f of 4. In other words, I'm supposed to take 4 and plug it in for x in the f equation. So that makes 2 times 4 minus 1. And 2 times 4 is 8. Minus 1 is 7. So my answer is 7. So it's just a two-step problem where you're supposed to put the number into the first equation, take that answer, and plug it back into the other equation. So let's try another one. So maybe you've heard of this called FoG. That's because it looks like it says FoG. It kind of looks like FoG. And this one maybe you've heard of as GoF. If you've heard it before, that's fine. If you haven't, no big deal. But that's what we're doing. It might have been more complicated last time we did it. Maybe it feels complicated now. Hopefully not. But we have f of negative 3. That's where we start. So we're supposed to do g of f of negative 3. So take our negative 3, plug it into the f equation first. And so we have 2 times negative 3 minus 1. That answer is going to be negative 6 minus 1, which is negative 7. Okay, so this negative 7 is now supposed to go into the g function. So I take and cross this part out because I turned it into a negative 7, and now I take that and plug it into the g equation right here. So it's just 4 over negative 7 minus 1. So that turns into 4 over negative 8. And that should reduce to negative 1/2. So my whole answer is negative 1/2. Now, as a side note, I've got a lot of students that they get confused. Part of the biggest confusion in this process is because they've seen teachers plug the number in here for the x and also over here. And so we get confused because we see the number get plugged in here, like if I had plugged in that negative 3. And we're not sure what we're supposed to do with that. You don't have to worry about this part. That just means that f of negative 3, all that means is when I plugged in the negative 3, the answer was negative 7. That's all that means. And you don't need that part. Okay, so you don't actually have to plug it in over here on the left-hand side for the x. You don't have to plug it in over here. It's nothing to worry about. So let's take a look at sometimes when we have to plug in an x, in other words, a variable, in place of the variable that was there. And now it would really make more sense if I had like a p here. Okay, so I'll replace it and then I'll put back with the x. But it's kind of like whatever the variable is here, you're supposed to do the same thing we were doing with the number. So in other words, here, if this was a p, what it's saying is take p and put it into the g equation wherever there's an x. So right here I would put a p in there, so I'd rewrite it to be 2p squared minus 4p. Okay, but I didn't have a p in the first original problem, so I'm going to erase it and write x. But I just want you to know that that's really what it's asking you to do, is put that variable wherever you see an x. So the original problem, and what you'll be seeing in most of your assigned problems, is it's just saying f of g of x. So it's really saying put an x wherever there was an x in the g equation. Well, there's already x's there, so you don't need to do that. So the answer for this part is 2x squared minus 4x. Okay? So now what we're supposed to do is we're supposed to put that in, this whole thing in wherever there was an x in the f equation. So over here in the f equation, wherever there's an x, I'm supposed to put this whole thing. And that's going to look like 1 over 2x squared minus 4x. Okay, so I'm going to write it down here. 1 over 2x squared minus 4x. Okay, now that would be the answer. It really is the answer. I can simplify it, and I'm going to, but it's because it says, and the domain, find the domain. Well, the domain means basically what can't x be. So can't x be. Okay, so what can't x be? In other words, I can't ever have the denominator equal 0. I can never have the bottom be 0. So what I'm going to do is I'm actually going to take the bottom and set it equal to 0. 2x squared minus 4x equal to 0, because I want to see what would make it be 0, because I want to know what x can't be. Okay, and then once we set it equal to 0, you need to solve for x, and we solve by factoring. I can factor out a 2 and an x from both of these, 2x, and I'm left with x minus 2 equals 0. So I would get two things that would actually make this equal 0. If I set this one equal to 0, 2x equals 0, and x minus 2 equals 0, my two answers that would cause this to be 0, this first one would be that x would be 0, and the second one would be that x equals 2. In other words, if x was 0, the denominator would be 0 down here. If x was 2, the denominator would also be 0, and that's a problem. What that means is that x can't be, in other words, the domain, x cannot be 0 and 2. Cannot be those two numbers. So everything else except x can't be 0 and 2. So if it ever asks you to do the domain, it's basically saying, well, you might have a fraction. Set the fraction, the bottom part, equal to 0, and see what x can't be. Okay? Now there's one final section that we need to make note of as far as these composition of functions go. And you'll see they'll be given f of a number. When basically you're looking down here at the line, and they're saying this particular line is f of x. And then they say, okay, well, find f of negative 5. Well, if it's f of x, what we're saying is that x is negative 5. The question is, what is the y value? So the y value when x is, and then it's whatever that number is. Okay, well, here the first number is negative 5. So we're really being asked, what is the y value? Because remember, f of x is the same thing as y. So we're really saying, what's the y value when x is negative 5? So we go to negative 5 right here, and we just kind of go up to where it touches. The y value, so you go over to the y value, is 3. So f of negative 5 is 3. Okay, so let's do another one. So f of negative 2. The question again is, what is the y value when x is negative 2? So go to negative 2, go up to the line right here, the y value, if I went to the dot, so basically I go up to where the line touches negative 2, and I get 6. So the coordinate here would be 2, 6. The answer part is the 6. That's the part that we care about. So f of negative 2 is 6. Okay? And one more. F of 4 means I go over to 4 right here, and I go up, see where it touches, and then see what the y value is. So basically the coordinate there where it touches would be 4, 2. The answer part is the 2. That's the y value. So f of 4 is 2. The y value when x is 4 is 2. So that's the question you should be asking yourself on these types of problems.